Hello class, we are on the last topic of vision. Yay! So without further ado, I will share my screen. It's going to be awesome. It's the ventral and dorsal streams. I hope you're ready for this. Current slide. All right, very last objective on the vision chapter 5, discussing the ventral and dorsal streams. So let's get into this. We know that ventral means stomach side, dorsal means back side, right? And for the brain, it's a little bit different, but we're going to mean dorsal is going to be the top of the brain, and the ventral is going to be the bottom of the brain. So we're going to talk about, of course, the brain here. But first, back to the visual system that you know. The fovea, the retina, right? So some cells are going to go from the fovea and some signals are going to come from the rest of the retina. And so we can start to parcel out these pathways even at the level of the retina. So basically what happens is different aspects of vision are handled by different pathways. And so brightness, shape, color, movement, all this is handled by different pathways. And we can start with two pathways, one coming from the center of the retina. We call that parvocellular. Parvo actually means small. And it's because they have small receptive fields. Remember, the receptive field is a little piece of the world that responds to this particular cone, that this cone responds to. And remember the midget ganglion cells, so they're hooked up in a way that each one of them has a very, very small area of the world that they respond to, whereas in the rest of the retina, we have a much larger receptive field. So there's the parvocellular, and those are mostly cells in the fovea, and then the magnocellular are cells from the whole retina, but usually around the fovea. They have very large receptive fields, and they're going to be involved, we're going to see, in movement, where the parvocellular field is mostly involved in recognizing space, shape. And then in the cortex, we're going to see that the paths merge for brightness and color. So let's take a look at that. Here you can see the parvocellular path all the way on the left side there. And we know that it goes from the fovea, where then you get hooked up the cones to the bipolar cells, to the ganglion cells, and then to the lateral geniculate nucleus, signified by LGN there. Then it's going to go out to V1, which is part of the occipital cortex. That's what we call the primary visual cortex. And then there are some other areas of the visual cortex that we also label with V. And so we get this kind of volley back and forth with V2, V4, and then finally to the inferior temporal lobe. Remember, that's down here at the bottom of the brain, the temporal lobe. And so that's your ventral stream. And the ventral stream is basically answering the question of what is this object? It gives us the shape of the object. It gives us the color of the object. It gives us the brightness of the object. And so it's basically, what is this object? So we call that the what stream, okay? Now, there's also a mixed path, and that mixed path is going to result in some movement perception there, and we'll get to that in a second. But let's go with the other major stream, which is the magnocellular stream, or the dorsal stream. And that, again, is coming from the whole retina. And remember, this is going to detect things very easily, largely because it detects motion very well, where things are. And so we're going to get, again, the rods are connected to the bipolars, connected to the ganglion. They leave the eye. They go for the lateral geniculate nucleus, just like we saw there. Also, we're going to get some involvement here from the superior colliculus, which you remember is in the midbrain, and we talked about it back in the anatomy section, that handles movement aspects of vision as well. Then we get volleying around from V1 and V2. And then we get basically a lot of it coming to the posterior parietal cortex, which remember is up here. So that is our dorsal stream, because it's at the top of the brain. And it really answers the question of where. We saw the posterior parietal before being in, well, no, sorry, we're going to get to that in our next section. Okay, ignore that. Anyway, posterior parietal is going to be involved in where things are. So that's basically, if I'm going to touch something, you know, I say I got my phone here, I'm going to reach out to my phone. I have to know where it is. It's not just seeing what it is or that it's blue or whatever. It's seeing where it is. And I need to be able to know where it is in order to grab it. And so here we have this, the dorsal stream will tell us where an object is. It doesn't really tell us what it is, but it tells us where it is. So these paths work together. This mixed path here is over in the middle temporal and the medial superior temporal, kind of in the middle of these of the dorsal and ventral streams. Have look at movement perception, so they'll be able to tell if something's moving or not. And when we get damage to those sections, we find that people see things in freeze frames. They don't actually see movement. So if they see a car going down the street, they'll see it as a picture of a car, a picture of a car, a picture of a car, a picture of a car. They won't see it actually moving. And so that some of these areas in between are going to be involved in movement perception. So the two main streams, what is it? Is the ventral stream, and that's going to be in the inferior temporal lobe. And then where is it? Is going to be the dorsal stream that allows us to act upon objects. And that is going to be the posterior parietal cortex. Okay. Here you can see the ventral and dorsal streams just in a picture of the brain. Here's the lateral geniculate nucleus. From there, we get this dashed line, goes all the way back to the occipital lobe, V1 and V2 there. And then the information is going to go out, either up to the dorsal stream or down to the ventral stream. And that's happening simultaneously every time we look at something. We know where it is, how far it is away from us. If we wanted to act upon it or walk up to it, we could, and that's the dorsal stream. And the ventral stream goes down and it tells us what the object is. Now, you never notice that these are separate. You never notice that. And it's because you don't have brain damage. But people who have brain damage do notice it. So some people can walk up to an object and act upon the object and pick up the object, but they don't know what it is because they have that ventral stream damage. And other people know exactly what the object is, but they can't walk up to it accurately because they have the dorsal stream damage. So we see damage in both of those. The ventral stream damage, they can't describe the size, shape of the objects, but they can pick things up. They don't bump into things. But they actually can't describe the location either. They can't say it's next to that phone over there or anything like that. But they can come and pick up things, and they don't bump into things when they walk, but they won't be able to describe the things in front of them. With the dorsal stream damage, they can describe the objects, but they can't reach out and get them. And they also can't describe the location of the object. They tend to bump into things, and they only avoid objects by hearing them. So they can't use vision to know where an object is if they have that damage in the parietal lobe there. Okay, we have a couple of problems here that I just want to put a name to. Visual agnosia is that you can describe visual objects, but you can't recognize what they are. So you might be able to describe, oh, it's shiny and it's metal, but you won't be able to say that it's a wrench or a hammer or something like that. Prosopagnosia is the inability to recognize faces. And there you can still describe the face. You can say, it looks like a woman, she's a young woman, she's got thick eyebrows, blah, blah, blah. And they can describe characteristics, but they cannot say, oh, that is the Lily, or that is Sarah, or whatever. So those are going to tend to be ventral stream problems there because they don't have trouble moving toward objects and stuff like that. They just have trouble recognizing what an object is or naming the object. And those are common with brain damage to some of those inferior temporal areas, again, usually from stroke. All right, well, check out that video to review the vision section. It's a really good video, I think worth watching. And I'm going to end this now, and we are done with Chapter 5 video lectures. Thanks for watching. You guys have a great day.